Good morning all. This is Dr. V. Hari Priya. I am working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology. So, in the previous session, we discussed about liquid fuels. In that natural existing liquid fuel, it is crude oil. How it can be extracted from the earth's core, where it is present, that means oil bearing region, where it is, how to locate, everything we discussed. And after extraction, how it can be subjected to refining. In that refining, through 3 steps will be included. So, and then final thing, it is fractional distillation, that is purification, and what kind of fractions they will separate out after reaching their boiling range. So, everything we have discussed in the previous class. So, let us go for today's overall view of my presentation. So, introduction to synthetic petrol, or we will call it as gasoline. How that petrol can be synthesized artificially, or it is also known as gasoline. How we are going to synthesize a gasoline or petrol, and then what kind of different methods are existing for synthesizing gasoline. So, these two topics we are going to discuss in today's session. Let us start with gasoline or synthetic petrol. So far what we have discussed, it is about a liquid fuel, that is natural existing liquid fuel, crude oil. So, that petrol that directly obtained from fractional distillation. So, during refining of petroleum, it will include 3 steps. Third step, it is of fractional distillation. So, after fractional distillation, we will get different fractions like petrol, diesel, kerosene, naphtha, everything. So, in that we will get petrol, which is known as straight run petrol. Straight run petrol, it is natural one, which is during purification of petroleum, we will get this straight run petrol. So, it is having certain drawbacks. So, let us see what are the drawbacks one by one. So, first and most important thing is, it is very laborious, at the same time it is very expensive, that is extraction of crude oil and subjecting that one to refining process. So, yield should be more. After extraction it is completed, we should get more percentage of, more amount of petrol. But here if you notice the percentage yield, it is only up to 20%. So, very poor percentage yield of petrol from refining of crude oil. And the second one, it is quality is also not so good. It is poor quality one, impurities will be more, and it is not having any kind of properties, that means say anti-knocking properties like that. So, it is to be blended before marketing that petrol, it is to be mixed or blended with some kind of additives, so that its properties are enhanced. So, that is the second drawback, quality it is very poor, and as I am telling you that yield it is very poor, that is 20% only, it will contain the middle and heavy oils as impurities. A lot of middle and heavy oil, it is mixed with that petrol. So, for overcoming these 3 drawbacks of straight run petrol, we are going to synthesize gasoline. So, this synthesis of petrol can be done in several ways are there, 4 different ways, but in our syllabus we have only 2. Cracking. Cracking is a kind of process in which heavy molecules were subjected to decomposition, so that small molecules will be produced. And the second one, it is Burgess method. So, during World War II, so these were introduced. So, let us go with the cracking first. So, for overcoming these 3 kind of drawbacks, yield is very poor, yield it is very poor, and then quality it is very poor, so that it is to be mixed before its marketing, and then impurities like middle and heavy oil are mixed with the straight run petrol. So, overcome in order to overcome all these what we say drawbacks, synthetic petrol can be produced by using any one of these 2 methods. So, let us go with the cracking process first. Before going to cracking process, I mean definition and how it is produced, let us see how it is able to overcome the drawbacks of the straight run petrol. That is what we call it as advantages of cracking process. So, as we discussed it, like yield it is very poor in the case of straight run petrol. So, in this crack, because of adopting this cracking process, yield it is better. So, when compared to the previous natural existing one, yield will be improved, and then quality is also better improved, and then no need for depending upon external fuels for cracking process. Heavy molecules simply, if they were subjected to this cracking process, they decompose to form small hydrocarbons which were acting like fuels. So, there is no need of external fuel for carrying out this cracking process. That is one more advantage. And then because of this cracking process, petrol producer will be having or it containing a composition of higher aromatic compounds, or we can call branched hydrocarbons. So, combination of these two also there is a chance to form. So, this is one more advantage. And then very little amount, that is within permissible limits, there is a little amount of undesirable sulfur content will be there because of this cracking process. If it is a naturally occurring one, there is a chance for more amount of sulfur content. So, because of preparing this gasoline in synthetic method, that is adopting cracking process, it is little advantageous that little amount of desirable sulfur content will be present. That means very less amount of sulfur will be there because it is highly toxic in nature. It is sometimes it is, we will call it as carcinogenic in nature, it is able to cause air pollution. So, because of these advantages, we are going to adopt a cracking process. So, let us go with what is cracking process, how it can be done or how it can be carried out, and a few examples, and then how many types of cracking are there. Let us go through that one. So, how the cracking it is defined? Cracking is defined as a decomposition of the process in which the decomposition of higher hydrocarbon molecules takes place into simpler low boiling hydrocarbons which are having low molecular weight. So, that means high molecular weight, higher hydrocarbons will be considered for subjecting to cracking process. As a result, they involve in decomposition, thereby producing very simple low boiling. Initially, it is having high boiling point. Now, produced hydrocarbons will have low boiling range with very low molecular weight. So, such kind of hydrocarbons will be produced, and that process is what we call it as cracking process. So, if you notice this example, the following example, I have considered decane and its molecular formula it is, if you notice, C10H22. That means decane, An means An represents, and it is an example for alkane. Alkane means it is having all single bonds. Dec means presence of 10 carbons. 10 carbons were present, and then it is an example for alkane, and it possesses a boiling point or a boiling range of 174 degrees centigrade. If this decane, whose molecular formula it is C10H22, and moreover it is an example for alkane. It is an alkane. It will contain only single bonds between carbon atoms. If it is subjected to decomposition, then we will get a mixture of two compounds. So, what are they? One is pentane, that is alkane again. Pentane, An represents presence of single bond. That means it is an example for alkane, and pent, it represents number of how many carbons? 5 carbons. So, 5 carbons, alkane with 5 carbons, whose molecular formula it is C5H12, and then pentene, ene is nothing but alkene. So, it is an alkene, it will also contain 5 carbons because it is pent, it is represented like according to nomenclature of organic compounds, it is having 5 carbons, and it will differ with the molecular formula in pentane, that is its molecular formula it is C5H10. So, one is alkane, other one it is alkene, a combination of these two will be produced. Two products we can expect, and their boiling point it is same, that is 36 degrees centigrade. See, this is a simple example for cracking process. As I told you, what is cracking? The process in which the decomposition of higher hydrocarbon molecules will be carried out to produce simple low boiling hydrocarbons which are having low molecular weight. So, that process is named to be cracking process. Here, I have considered higher hydrocarbon, that is decane, and its molecular formula it is C10H22, and it possesses a boiling point of 174 degrees centigrade. So, if it is subjected to decomposition, then we can expect two different products, one is pentane, other one it is pentane. They differ in their number of bonds, that is sigma bond and pi bond, and then molecular formula, but they possess same boiling point, that is 36 degrees centigrade. Okay. So, this cracking it is usually adopted in order to break the heavy oil to form petrol or gas oil. In general, for preparing, this is a generalized example for cracking process. So far what I have explained. Now we are directly switching over synthetic petrol or gasoline preparation, and this can be done by adopting this cracking process. And best raw material we are choosing for carrying out this cracking process, it is heavy oil we have to consider. Heavy oil is first fraction that gets separated out in a boiling range of 360 or 380 degrees centigrade when petroleum it is or crude oil it is subjected to fractional distillation, that is refining. Okay. So, that heavy oil we are going to consider it as raw material for cracking process. Heavy oil we are going to consider. So, if it is subjected to cracking, that means it will decompose to form petrol or gasoline, which is having very high quality and yield is also very good when compared to straight chain petrol. So, this can be done in two different ways. One is or two different types of cracking are existing in nature. One is cracking, thermal cracking, and other one it is catalytic cracking. So, thermal cracking means it is normal cracking process, that is decomposition, but in the presence of some amount of temperature, that is why it is named as thermal cracking. So, that reaction takes initiation by supplying certain range of temperature, then only heavy molecules like heavy oil were involved in decomposition process, thereby producing petrol or gasoline. So, that is what we call it as thermal cracking. If the cracking process it is carried out by using temperature as an experimental condition, certain range that we have to supply, so that it is able to involve in decomposition, that is heavy oil, to produce petrol or gasoline. And the second type of cracking, it is catalytic cracking. So, this catalytic cracking name itself represent, we will make use of a catalyst for carrying out the cracking process. So, along with some amount of temperature we need to supply, that is must and should for any reaction to take place. But in this second case, we are going to carry out this entire cracking process by supplying some amount of temperature as well as in the presence of a catalyst. That is why it is called catalytic cracking. Again, it is subclassified into two different types. One is fixed bed and the second one it is moving bed. So, as far as our syllabus it is concerned, we have moving bed catalytic cracking in our syllabus. So, let us go with that moving bed catalytic cracking. So, that means as per its definition, in moving bed catalytic cracking process it is carried out, that means subjecting heavy oil or any other kind of higher hydrocarbon to decomposition in the presence of some temperature range, low temperature range, as well as in the presence of a catalyst, proper catalyst, that raw material which we have considered will involve in decomposition to form petrol or gasoline. So, let us see. Yeah. So, moving bed catalytic cracking. So, in this, if you notice its apparatus, or we can say what we are going to consider for carrying out this process. So, this is a kind of retort or furnace which is provided with one pipeline, and this pipeline it is having an inlet opening that is meant for allowing the passage of feed oil. So, what were allowed to pass into this one to carry out the catalytic cracking? Let us see one by one. So, the solid catalyst is taken in the form of a fine powder. Solid catalyst, it can be like fine powder form. Solid means crystalline and amorphous, both will exist in nature. So, it is grounded like a fine powder. So, that solid catalyst it is considered in this case, which is then made in the form of a fluid, or we can call it as a slurry, like a paste. It is converted to in the form of a paste, so that it easily flows through a stream of gas when it is allowed to pass through a stream of gas. If it is made in the form of a slurry, or we can say fluid, then easily it will flow through that gas stream. So, that is why we need to make a fine powder of solid catalyst. Okay. So, and then as I told you, heavy oil we are going to subject with. So, the vapors of heavy oil are first mixed with fluidized catalyst. Initially, what we need to do, that solid catalyst it is made in the form of fine powder, and then it will be converted into fluidized form, and then this initially this heavy oil, by allowing it into the furnace using this pipeline, we have to allow the passage of heavy oil. So, there it is subjected to heating process by supplying some amount of temperature more than 400 like that. So, that it involves in or it is easily converts into 350 like that we have to supply, or 300 itself it is enough because it is heavy oil. Okay. So after allowing the passage into that retort, which is maintained at 300 degrees centigrade, so immediately it involves in evaporation so that its vapors will be released. So now these vapors along, that means they were mixed with fluidized catalyst, are allowed to pass, or they were forced into a reactor which is maintained at 500 degrees centigrade. So if you notice this apparatus, so this is the retort used for converting that heavy oil into vapors by subjecting into heating, and then it is mixed with the solid catalyst which is in fluid form. Here it is mentioned catalyst plus oil, and it is then allowed to pass into this reactor where the temperature it is maintained at 500 degrees centigrade. Okay. So after that, in the reactor what will happen, as we know that this is example for cracking process. We use a catalyst which is made in the form of a fluid, and then raw material, it is vapors of heavy oil mixed well and then sent into this reactor which is maintained at 500 degrees centigrade. Then cracking will take place, that means decomposition will take place. We can expect heavier hydrocarbons decomposing to lighter hydrocarbons, that will take place. And if you notice at the top of these two, this is reactor and this is a chamber that is meant for regeneration of catalyst. Okay. So if you notice these two chambers, at the top we are having two kind of things. This is nothing but a cyclone separator. These are what we call as centrifugal or cyclone separator. What is the role of using the cyclone separator is, it is able to filter flue gas. Flue gas means whenever any fuel it is subjected to combustion reaction, it is able to release some kind of mixture of gases as products. So it will have a mixture of CO, oxygen and very trace amounts of CO2. Mixture of these three is nothing but flue gas. So for any fuel, if it is subjected to combustion reaction, we can expect this formation of flue gas. Until and unless if it is not reduced to permissible limits, that means its concentration if it is not reduced, we cannot release that flue gas into the atmosphere directly. So these two cyclone separators or centrifugal separators I told you, which were fixed at the top of the two chambers, one is reactor and the other one is regeneration chamber. So these are able to filter this flue gas, and then safely with this help of this outlet, it can be safely released into the air or atmosphere. So that is the role of this cyclone separators. So and then this cracked vapors of heavy oil, I mean to say heavier hydrocarbons, they crack to or they decompose to lighter hydrocarbons. At the top, if you notice, after the cyclone separator, these vapors are allowed to pass into a tall fractionating column. There they were subjected to refining, that is using fractional distillation, just like what we have done or what we have discussed in refining of crude oil. Same thing we are going to carry out here. So after this refining it is done, that petrol that is produced, that is lighter hydrocarbons, are then subjected to involving in cooling process with the help of a water jacket, in which is provided with one pipeline. This pipeline it is used to carry that produced gasoline. So it is cooled to room temperature. During this process, if any gases were produced, one outlet it is there for releasing those gases. As these are not harmful, directly we can release into the air or atmosphere. So and then that synthetic petrol that is produced is then allowed to pass into a stabilizer, where again entire purification or refining takes place, so that the outlet provided at the bottom of the stabilizer, where we can collect gasoline, that is synthetic petrol. There is a chance for formation of heavy oil, unreacted one, during this process, that can be collected from the bottom of bottom part, that is, or bottom of one outlet, it is connected to tall fractionating column. Okay. Here if you notice this entire figure, one more chamber as I told you, which is fixed with the cyclone separator, we can see in this picture, that is catalyst regenerator. Okay. Catalyst regenerator. See here, the catalyst gradually becomes heavier due to coating with carbon and settles at the bottom of the chamber, where it is forced by an air blast to regenerate that catalyst by maintaining a temperature of 600 degrees centigrade. Okay. So in this chamber, we are maintaining the temperature of 600 degrees centigrade. As this process it is going on continuously, we can expect that burnt carbon formation at the bottom of this chamber, so that catalyst gets exhausted. So how it can be regenerated means by blowing hot air which is maintained at 600 degrees centigrade. So using this hot air blaster, it is allowed to pass into this chamber, so that that catalyst can be regenerated. So this is what it is mentioned here. In this regenerated, the carbon it is burnt into CO2, and then the regenerated catalyst then flows through the standpipe for mixing with fresh batch of cracking oil, and at the top of that regenerator there is one cyclone separator which is able to permit only gases which were filtered, that is CO2 like gases, and then holds back the catalyst particles, so that smooth running of cracking process can be carried out. So this process of regeneration of catalyst and its subsequent usage in cracking of heavy oil will continue forever without any wastage of time. So it is a continuous process, there is no break or we can say there is no kind of batches in this process, we cannot go with that one. So it is a continuous process, and that is why it is far better when compared to fixed bed catalytic cracking process. So this is up to today's session. Coming to summary part, so far what we have discussed is, we started with synthetic petrol, its little bit of introduction, and what kind of methods we can adopt for preparing synthetic petrol. One is cracking process. Synthetic petrol can be prepared by cracking, and again cracking it is of two types. Introduction I have explained, and then one example I told you for a cracking process, and then it is of two different types. One is thermal cracking, second one it is catalytic cracking, and then directly I switched over to explaining about catalytic cracking. What fuel, what raw material we are going to consider, it is heavy oil. It is then subjected to evaporation, and then those vapors are subjected to cracking process, and then finally to refining, so that petrol it is produced. So that's all for today's session, or in the coming session we will go with other methods of synthetic petrol preparation. That's all for today's class. Thank you so much.